Hi, I'm Meghana Rao. Today I will be showing you the Deep Learning SDK from Intel. Data scientists and software developers can use the Deep Learning SDK to simplify installation, easily prepare models using popular deep learning frameworks on Intel hardware, and optimize performance for training and inference on Intel architecture. The Intel Deep Learning SDK is a free set of tools to develop, train, and deploy deep learning solutions. In today's presentation, you will see a live demonstration of the DLSDK training tool and learn how to visually set up and tune and train datasets using deep learning topologies like LeNet, AlexNet, and GoogleNet on frameworks like Caffe, optimized for performance on Intel architecture. Now let's take a look at the training tool. You can download the DLSDK installer for Windows or Mac from the link provided in the description below and install it using the instructions in the user guide. Launch the tool on your host machine using the IP address and port of the server on which the DLSDK is installed. Once launched, the home screen looks like this, and it provides the ability to upload images and create and train a model. Let's take a look at an example. I will use the MNIST dataset for demonstration. Before uploading the dataset, make sure that your directory structure has the labels at the highest level with data corresponding to each label within. Now the first step is to upload the raw data. Go to the Uploads tab, create a subfolder in the root path provided, select your data file and upload. Once uploaded, you can copy the source path for your dataset from the History tab. Now let's create a dataset. Provide a name for the dataset, a brief description, and choose the percentage of data from the raw dataset that you would like to use for training and validation. The MNIST dataset has over 60,000 items. You can experiment these by varying the percentages. The MNIST dataset images are all 28 by 28 grayscale, so make sure you select the right option in the Image Processing tab. If using color images for use with topologies like AlexNet and GoogleNet, the processing options must be set accordingly. Check out the user guide to learn more about the other processing options. Now go to the Database Options tab and choose the database backend and the image encoder. Now you are ready to create the dataset. Once successful, you can visualize the number of data items in each label for the training and the validation datasets. Let's now go to the Models tab, select the right topology, and train the model. LeNet is one of the topologies that works best for handwritten digit recognition, so we select this. AlexNet and GoogleNet work best for color images like CIFAR10 and ImageNet. You can also edit the built-in topologies using the new custom topology feature. Edit the topology file in the text field and save it. It's now ready to use to train a model. Additional data transformation capabilities exist within the DLSDK to create a richer dataset. We do not cover them here, but you can learn more from the user guide. Next, we move to the Parameter Selection tab. Based on the topology chosen, the hyperparameters are all by default set to the optimal values. But you can experiment by changing some of these values to see how the accuracy and the loss functions change. Now, run the model. After all 15 epochs, we see that 100% training accuracy and approximately about 98% validation accuracy are achieved. You can validate the model by going to the Testing tab, input a random digit that's not part of your validation dataset to see what the model spits out as potential matches. For each label category, you can also see the number of hits and misses. After training is complete, the set of all Caffe files for the trained model can be downloaded and used on the deployment platform, for example, a smart camera or other mobile platform. The real-time data fed to the model on the deployment platform can then predict an outcome based on the trained model. Thanks for watching. You can learn more about the DLSDK on IDZ and download the tool from the link below. Make sure to like and share this video and subscribe to the Intel Software channel.